classic story. All right, so we're also going to check for, I've got my calculator here ready to go. We want to make sure that we check for extraneous solutions because they will definitely pop up. All right, so I see the d here inside the exponent, so we're probably going to need a log to get that down, maybe. Sometimes we might be able to get a similar base. So let's see what happens here. We've got 1/2 being squared, so that's 1/4. Okay. Okay, now if I multiply both sides by 4, now these two will not cancel out. He has an exponent, so this is actually an illegal move. You might want to kind of consider this as a very separate thing there, because this is a base and this is a multiplier. So this would actually look like this. Once we multiply both sides by 4, you'll undo it here, but you will also have 4 on the other side. So now we're in a situation where we have a similar base. So 3d actually equals 1. We can just ignore the 4 in the same way that we could ignore those logs here. Okay. So d would actually just be 1/3, and we'll see here that 1/4 times 3 times 1/3 would be 1, so that's 4 to the first. So 1/4 times 4 indeed equals 1. So we're all good with that. All right, so we got some negative exponent. I got a feeling this is also going to be a similar base, because 243, what is that? Something to the 3rd power. 3 to the 5th power? Yes, 3 to the 5th power. So let's make this all. There's actually a couple different ways you could do that. It's going to be 3 to the 5th, and this is going to be 3 to the negative 2nd times negative u equals 3 to the 3rd times negative u to the 5th. Okay, so pause for a second and just kind of wrap your head around this. We converted everything to a base 3, and it would have had to have been 3 in order to make this work. Okay, a 9 would not have worked because this would have had to have been a 6. But anyways, what we're going to do here is we're going to raise this to, that becomes a positive 8. I'm sorry, I treated that as a 4. That should be a 2u equals 3 to the negative 15u. All right, now we still don't have the same base yet. We're going to have to bring these two together so that 5 plus 2u equals 3 negative 15u. So we've got to add those two together because they're the similar base, just like this. Whenever you're in doubt, just remember that this would be, rewrite something simple so you can remember what the exponential properties are. And so these guys add together. So here, this 5 does not become 10u. It becomes 5 plus 2u. Okay, that becomes negative 15u. But this you did multiply. But when they're separated like this, the bases are, then you are going to have to add them. So watch out for that. We're now in a position to cross out the similar bases. Okay, we're going to move that 2 over to the other side. It'll become negative 17u. And then u actually is going to be negative 5 divided by 17. Okay, now that's strange to me. I don't know about that number. Put a little asterisk. We'll double check that. It's really hard to tell whether or not this would work. It just doesn't seem right. I feel like I made a simple error here. 3. Let me double check real quick. You can go ahead and just skip forward. That would be 3 to the 3rd, negative 5u, negative 15u. No, that definitely could be right because this is a large number. Okay, yeah. All right, I'm going to trust that. Okay. Continuing. There's no way to get a similar base here because 18 is not a perfect square. Yeah, we're stuck here. So we're going to have to isolate this 18 to the 3n. We're going to have to move that 4 over to the other side. So he will become 53. Now, you might be thinking that I could divide by 18, but you cannot. What you've got to do is take the log. And it can just be log base 10. That's all you need to do. Your calculator is going to come in handy here. We're going to divide everything by 3 and by the log of 18. So you can just do kind of two things in one step. Divide by the 3 as well. Okay. And then whatever that number is, that is your answer. Okay, so we got the log of 53 divided by parentheses 3 times the log 18. Okay, so I want you to kind of see this here, that I do have to divide by both of them. If you enter into the calculator, I want to just show you a common mistake that I see. It's worth going over. Okay, what's going to happen here is if you do this, you are telling the calculator to only divide by 3 and then multiplying by the log of 18. That would be the same thing as having the log of 18 up here at the top. Okay? That's what that would look like. Okay? That's what you're telling the calculator to do right here. So, just be careful. You can wrap the denominator in parentheses like this, or you could just do it like this. Okay? Divide by 3, but also divide, log of, I didn't even hit the, what is the name? Log of 53. Divide by 3, and then also divide by the log of 18. Okay? That actually does work. Oh, we got it right here. 0.5, then we're going to go 8. Okay? So let's go up here. Yep, so you'll see that it's the same number, okay? Okay, so moving forward, okay, we did a lot of these. These are great things to do because they'll help you kind of solve practical things down below. I've always enjoyed these. We're going to add a positive 5, so that becomes a negative, I don't trust myself at this time of night, plus 5, negative 139. Okay, then we're going to divide by 6. Okay, that is not cool. So we're going to have e to the x minus 2 equals positive 139 divided by 6. All right, because that's negative, so we're going to get a positive number. Okay, so now we got to take the ln of both sides. So that would be x minus 2 equals the ln of 139 over 6. And that would then, this would be times the ln of e, which is just 1. So now x equals the ln of 139 divided by 6 plus 2. And I can actually just do this. 139, the ln of 139 minus the ln of 6 plus 2. That actually, right there, is expanding. So I don't know. If you're good with this stuff, you might be able to remember that you could do something like that. All right, so x equals 5.143. Okay, we're not gonna, we don't have to worry about a negative on the inside of these logs because there are no logs. Okay, now 36, we are not gonna put that on the test. This is, it's kind of surprising how something so simple could produce such a difficult problem. But we're not gonna do that. I have never seen that in a calc class, okay? So I just never seen it. I've been doing this a while, and have not seen that. So we're not going to do that because it would take half an hour, and that just doesn't seem right. So I'm going to subtract 5 from both sides. I'm going to divide by 7. Okay, but remember, these are calculator problems, so we're not going to sweat that too much. We're just going to put 15 divided by 7. We're going to leave it there. I am going to take the log or the natural log, whatever you want, as long as you're consistent. So we'll just take the log. So the log, we'll put the 2r plus 7 in front, and then we have the log base 9. That's going to equal the log of 15 over 7. okay, which is the same as the log 15 minus the log 7. So you want to do that. So now we got 2r plus 7 equals the log of 15 over 7 divided by the log of 9. Okay, but then we're going to subtract 7. Okay, so now those guys are by itself. Then we're going to take that whole number there and then divide by 2. Okay, and then that's going to be your r. Now, I will go ahead and type it in the calculator just so that you can verify it. But if you calculated the decimals as you along the way, that is absolutely fine. Like maybe you just calculated the log of 15 over 7, on your own first. You got a decimal, you wrote it down, cool. Okay, now leave that decimal there with all of the places. Then we're going to divide by the log of 9. Okay, there's the next. Then we're going to subtract 7. Okay, and then we're going to divide by 2. So we have a r that equals negative 3.327. Okay, now what I'm going to do is I'm going to test this really quick. I'm going to plug it in here. I'm going to go multiply by 2 plus 7. The 9 to that power equals that times 7 plus 5. It equals 20. All right, so I just plugged it in and carried all those decimals with us. It's pretty cool that right there times 7 gave us 15. It's like the calculator knew what we were doing. So that's cool. Okay, so this is definitely the answer because we plugged it back in and checked it. Okay.